Hello, welcome to my channel. Today I will show you how to implement some numerical algorithms in Matlab or in Octave. So first of all, let's create a file. Just create a file called like tutorial1 in somewhere in your directory and open the Matlab from here. And what you gotta do is let's create a new script from here. So we have created a new script, and from here, so let's say I will just here, for example, let's go to the exercises. I think it's better to learn is to use exercises if you want to learn something really better. So for example, we have a bunch of questions here. I'm not sure if you are really comfortable with like taking derivatives or calculating the integrals. For example, let's start with the first one, hand calculations for the trapezoid method. So in this lecture I will show you how to implement trapezoidal and midpoint methods, and then in the next lectures I will go through the Monte Carlo algorithm. So first of all, let's check what is a trapezoidal function. What is a trapezoidal function, to be honest? So let me open you so let me show you what is actually a trapezoidal. So let me try you again. So basically, what is a so trapezoidal function, a trapezoidal method. Okay, so what do we mean by the trapezoidal method? So let's say we have a function like let's say it's x squared. This is x squared for x is greater than 0. X is greater than 0. So what do we mean by the integral and what do we mean by a derivative in this case? So the derivative is basically the rate of change of a function. So for example, for the x squared, the rate of change, the integral, the derivative can be calculated by, for example, if you are familiar with the derivatives or the integrals, we can just say that the derivative of this function is basically 2x, which means that this function's rate of change is linear. So for example, this is the linear rate of change. But what do we mean? So the derivative is actually giving us or showing us how a function is evolving or how a function is going to behave. But what do we mean by the integral is basically this field, this area below the function. So for example, for a function like x squared, basically to take the integral between, let's say, point 0 and a, to take the integral between 0 and a of this x squared function is basically to check this area. So let's say a is 1 in this case. A is 1. So what is in mathematics, in the integrals, this is x squared dx, which means that there is a function that when this function is being integrated, we have a derivative like this one. So we need to go one level up and say that x cubed over 3 may be this function plus a constant, but in this case, since we are calculating for a point in x, we are just supposed to, this is the exact integral of this function between 0 and 1. So then we check this 1 over 3 minus 0, which is 1 over 3. this case. So this is so to take the derivative, to take the integral of a function like in the exact way is really easy by calculating by hand. But when it comes to the larger functions, like the very complex functions in mathematics, calculating all of these functions by hand is such a cumbersome way of dealing with the problems. So for example, we need to introduce something different in this case, and we can basically create algorithms or the functions that can approximate the real value of an integral in a very accurate way. So for example, in this case, we can write here, in this lesson I will show you the trapezoid and the midpoint method. So what do we mean by the trapezoid method? So what do we mean by the trapezoid method? Trapezoid method. So we all know the trapezoids. So like if you just make a quick research on internet, you can see that trapezoid is something like this, and the area of the trapezoid is a plus b over 2 times h. This is the height. So something like, you have something like this. This is not a good trapezoid, so let's say a, b, and we have the h. So the area of a trapezoid is actually a plus b over 2 times h. So this is the area of the trapezoid. So how do we basically end up having this area? Well, I remember from my high school mathematics that, for example, if you have let's say if you have a triangle like this, and if these lines are parallel, you can basically take this point and you can carry it here, and you can end up with a triangle like this, and the area of these two triangles are actually equal. So we can say that A1, if this is A1 and if this is A2, we can say that A1 is actually equal to A2. So in the trapezoid method, we basically have these more or less the same thing. So you can just carry this point. As you can see, this is A times h over 2, and you can see that this is b times h over 2, so we end up having the area like this one. So for example, so when it comes to the trapezoid of this particular function, is that we will assume that we have a shape like this. Maybe I can use another color here to show you. So for example, our trapezoid will actually like this. Oops. We have something like this. Actually something like really this. As you can see, in this trapezoid, the shape is actually not, we assume that this is a really small point. We have something, a trapezoid like this. We know that there's a, this is, how to say, when we, in this case, when we put f0, we get 0, but let's assume that we have a height here. So we have something like this. This is A, this is B. So the area is A plus B over 2. What is the h here? H is this distance, which is 1. So if you see, if you check that with just one unit step, in just one in one, how to say, we call it, this is n, which is the number of the intervals of the trapezoid. So if this is 1, in this case you can see it's 1, so we have a plus b over 2. So what is a? When you give 1 to the function, you end up having 1, so which is 1 over 2, 0.5. But what is the real value of real value is 1 over 3, for example. So we have a very large error here. This error is can be calculated by, for example, the exact value was 1 over 3. What we ended up having is 1 over 2 over the real value times 100. So for example, in this case, by the way, this is the apps, so it's an absolute value, so we're gonna end up having 1 over 6, as you can see, times 3 times 100. So we have 50% error, which is such a huge error in this case. So let me go on and to tell you that. So we started with the x squared, function x squared. Such a pain in the ass to write. We have something like this. So, and we want to find this 0 and 1, this area. So what we are gonna have is that we will actually divide this, and this division, this h, is actually 1 minus 0 over n, and n is the number of the division. So for example, let's say n is 5, so h is gonna be like 1 over 5. So in every 1 over 5 we will have different trapezoids. This is 1 over 5, 2 over 5, 3 over 5, 4 over 5. So we can be 1, 2, 3, 4, 5. So we have 5 trapezoids. Before coming to how the algorithm is written, actually we need to check what is the interval. So the general definition of an interval is that a, b, for example, we have a function like fx dx. Between this a and b, trapezoid method tells us that this interval can be calculated by between a and b with 5 trapezoids, which is 1 over 5h. So what do we mean by that? We take this trapezoid, we add this one, we add this one, and we go on continuing. So which is a, and from a to where? From a to basically a plus h, from a plus h to a plus 2h. It actually goes like this. But the main point here is that we need to see something here. This h value h, which is the same in every trapezoid. So we gotta see a point here, which is h times, now h times the whole of this h times the whole a plus b over 2's in this point. So this function plus this function over 2, this function plus this function over 2, and here we end up having something like this. H times the first one. The first one, as you can see, f0 is 0, so we have f1 over 2, or basically, yeah, something like this, and we have f2 over 2, but here, so f0 over 2, f1 over 2, plus f1 over 2, plus f2 over 2. So what we were going to end up here is that here we also have one f2 over 2. This will go until n minus 1 over 2 plus fn minus 1 over 2 plus fn over 2. I'm not sure if you can follow it, but my writing is not actually very good. So h times f1 over 2 plus, Here this 1 over 2's show us something. This is the sum of n from equals 1, wait a minute, until n minus 1, fn minus 1. So this is like until n minus 1. I is like starts from 1 until n minus 1, which is fi plus fn over 2. So this is the general formula. As you can see, these values have, so I mean we will have an algorithm which is, this first value will going to be result, which will have fa, which is, I mean fa is the starting point. Actually in this case this is wrong, this should be 0, which is fa plus fb. What is the fb? This is the a is the starting point, in this case is 0, and b is the ending point, which is in case 1. So result will start calculating this value, I mean over 2 of this value, because we have f0 over 2 plus fn over 2, so over 2 here. And then we will keep adding this f1, f2 and f3 along the way until fn minus 1. So let's create a algorithm with Matlab. So for example, we'll have a function called and this function will return basically the integral of a integral trapezoidal, let's say, and the name of the function is trapezoid. This is trapezoidal, and this function takes a function, a starting point, an ending point, and the number of the division. So now we need to first start by telling what is the result. Result is actually fa plus fb over 2. So what do we mean by that? First, the result will be fa plus fb. And then for n from 1 until n minus 1, here I made a mistake, for n, how we were actually writing this, let me check. For loops in Matlab. So yeah, as you can see, for is going to be n, for n equals from 1 to n minus 1. I'm not sure why this, okay. And then we will keep adding result equals result plus, here we need to actually make this sum symbol. So here we will say fn. Okay, and we should not forget that the h is basically b minus a over n. This is our h, and then we need to multiply this h. So then integral trapezoidal is actually h times this result. So how we can actually see that, wait a minute, it was to save trapezoidal.m. How we can check that the function is actually working? So for example, we can have a function first, which is, let's say, which is called v, and to say that this is actually a function of x, and this function is basically, let's say, in our case it's x squared, so we know that. So as you can see, the v is now it's x squared, so we need to basically let's first find the exact solution. So what is the, like, which value is the derivative of this function? I show it with big V, which is x cubed, right? X cubed over 3. So the exact solution is basically v1 minus v0. So let's see the exact solution. As you can see, exact solution is 1 over 3, which is like 0.333. It makes sense. So let's look at our trapezoidal function. So we will trapezoidal. We send this function to v, the starting point, which is 0, right? Ending point is 1, and the number of steps. Let's say we have first step. Let's check if it's first step. In the first step we get 1. So what we got in the first step, I don't actually remember. 1 times 1 was in this case, okay, how many steps? Only 1 step. So I have made a mistake here somewhere probably, and I ended up having, this is 1. In the first step we should get something like, we got 1 over 2. Okay, okay. So in this case we send n as 1, so h was 1. H was 1, so fa plus fb was 1. N was from 1 to, okay, here we had a problem. For example, this should be I, and this should be I. Now save this file. Okay, we got it. Okay, let's try, for example, trapezoidal v01, this time 5. v01. I had a problem with the algorithm probably, so result fa plus fb over 2. We forgot the over 2 here. Now save it. So in the first we got this one. Let's say we have 5. If we give n is 5, answer is somewhat very big value. F1, F2, F3, F4 and F5. So we give n5, 1, 2, 3, 4 until 4. So let's give 100. So I clearly made a mistake here, so let me check how can I actually check this? Trapezoidal Matlab function, let's say. From I to I, let's open this. From I to n minus 1, x is a plus ih. So let's look at the, so wait a minute. Let's look at this previously written function. Here, I think the thing I made the wrong thing is that this function is actually should take into account the starting point, and this f should get bigger. For example, in this case, this is a trapezoidal, right? So yeah, the thing is, this should get not fi. This should either get fa plus I times h. So why we do mean by that? In this case, for example, in the function we were showing you here, in the function, okay, here we actually, this is the h values are the same, but here we ended up having f1s, f2s, f3s, these consecutive values, but these are actually the I value, these are actually fi, but I is this starts from a plus, for example, in this case, something like, let's say we have an x squared function. Let's say we have 3 steps. This one, and this one. So first one, which is f0 plus f0 over 2 plus f1 plus f2 plus f3 plus fn over 2. But this is the starting point, this is the ending point. But these values, we have the time h, but these values are actually, for example, f1, f2, these are actually fa, this is f at this point, say 1, plus this value is actually f1 plus f0 plus h times 1. This a is the starting point, right? f0 plus h times 2. This point f3 is f0 plus h times 3. So this function actually should take not only the I, f1, f2 and f3. This should take the starting point plus I times h. Here, this part. Okay, now our function is ready. Let's call it. But first I think we need to save it. Now let's call the trapezoidal with 5 steps. Now we have something better. As you can see, we are close to 0.333. We can check the error like error equals n squared minus. We know that the value is 0.333. We have something like this. if you make like times 100, so we have 0.67% of error, which is a really good result. But actually there is a better function than trapezoidal, and this function return, this function is called not the trapezoidal, this is midpoint, return midpoint. Also takes an f, a starting point, an end point, and a number of steps. Let's now talk about the midpoint. Midpoint method. I've been using Matlab 2014a because I'm in Ubuntu. I couldn't find any cracked software, and it's a very old one. It's been like 10 years, I guess. And you can see the midpoint. Now let's check the midpoint method. Midpoint method is somewhat very strange, because one would assume that instead of dividing a function by trapezoids would actually end up providing really good results, but actually midpoint method is a better way, and it uses these rectangles. So what I mean by that? Let's say now, let's again look at x squared function. X squared function, and let's say we want to find the area below this function, like this. This is the starting point 0, this is the end point a. Now, what do we mean by the midpoint method? Midpoint method is, again, we have h, which is starting point A, ending point B. Let's change the indices. A, B, which is B minus A over N. N is the number of the steps we will take. For example, you see, now H is this value. So if we have, let's say, infinite number of N's, now this h goes to 0, and we only need the function value. So if you have the function value here, let's say x is somewhere between a and b, now fx times h is fx times h. H is a really small value. So let's say but let's say h is 1. If h is 1, you divide this into, let's say, 5 steps, and if h is 1, you basically sum the f values, because h is such a small value that the sum of the function at that point can be seen as the area of that point. Okay, so how do we actually demonstrate this? We need to have the h and we have the f. In every point we have the h, so h is gonna be, we'll multiply by h. But at this point we have something different here. So now we have the value, so fa plus I. Okay, so I will just check a function from here. This is the rectangle method. This is the visualization of rectangle method. So, for example, what we do is that if we have, let's say this is just 1, and by rectangle method, let's say this is 5, and we divide it by 5 steps. 1, 2, 3, 4, 5. This graphics tablet sometimes makes me very annoyed. Let me show you again here. So okay, now what I tell you is that now we have a h like this. We need to take the middle value here and divide by h, as if this function has already been calculated. So h times f a plus I times h, and we sum these f's. For example, this is actually like a h times this, and starts from this I starts from 1, I starts from 0 actually, and I ends up as n, I from 0 to n, yes, starts from n, and we have f a plus I times h, I0 f a, I1 a plus h, a plus h. But since we take the middle value, we need to take this a. For 0, we need to take, for I equals 0, we need to take fa. For I1, we need to take actually fa plus h over 2. So I think it's something like this. So for I, we will take fa, we will take fa plus h over 2. And for I equals 2, so wait a minute, I think I made a mistake here. There's previously written function that's called a midpoint method, midpoint.m. So yeah, a plus h over 2 times ih. So here what we do is we, in this function, fa plus h over 2 inside the function plus I times h. So for I equals 0, we are here a plus h over 2. For I equals 1, we are in a plus 3h over 2, which is here, a plus 3h over 2. So it goes like this. And now let's write the function. So first we will take that return midpoint will be 0. The h is b minus a over n, our step. And then we have a for loop for I until, in this case I is gonna go until in this case we don't have it goes until n minus 1, from 0 to n minus 1. What do we mean by that? For example, let's say you go from 0 to 5, you have like 5 steps, and for 0 you have this point, for 1 you have this point, for 2 you have this point, for 3 you have this point, for 4 you have the last point. So it should go until I n minus 1. So I is going to be go until 1 to n minus 1. And here result is going to be result plus f, we written here, fa plus b over 2, this is the first one, plus I times h, yeah, it's going to be like this, and then we need to multiply this result, I mean, return midpoint is going to be result times h. So let's, it says the values variable might be unused, but I used it, which means I didn't save it. Save midpoint.m. Well, let's try it. Let's try the midpoint method. Midpoint v from 0 to 1 with 5 undefined function or the variable result. So here actually because we need to have start the result from 0. Now here we have a result value. Now we have approximated this in 5 steps as 0.84. Let's say in one step it doesn't reveal anything. In 100 step does it make sense, or I made a mistake probably again here. You can check. Result, what is the return midpoint? Here a plus h over 2, it's supposed to be a plus h over 2, and let's save it. Yes, now we have something better. In one step we have 0, in 5 steps we have something close. So this is the midpoint method. So to compare which one is, let's compare the error in this case. In trapezoidal, the error trapezoidal is exact solution minus trapezoidal v with 0.5 in 5 steps times 100. This is the percentage error, it is they call in mathematics. So let's see error trapezoidal. Error trapezoidal, if you take the apps, wait a minute, error trapezoidal 0.5 in 5 steps. So let's see the error midpoint, exact solution minus midpoint. So what is the exact solution? This. What is the midpoint? V0.5, which is something very bigger. So what is V, by the way? V is x squared. X squared function. It's with 0 and 5. This is something predictable. So let's see 0 and 1 in 5 steps. Now it makes sense. Trapezoidal V0, 1, 5. Okay, now exact midpoint, exact solution minus midpoint V05 steps, exact midpoint times 100. So this is the error. Okay, I had a mistake here, because to calculate the absolute error we need to divide this by the exact solution as well. So exact midpoint should be like exact solution minus midpoint V015 divided by exact solution. And then we need to multiply by 100. When this reveals. So 1.6% error in the midpoint method. Check in the other one. So let's say it's gonna basically the same thing, but we'll just change the variable. Copy, paste. In this Matlab, the copying and the pasting is, I think copying is Alt W and pasting is Control Y. Now is the trapezoidal. Exact trapezoidal. Now exact trapezoidal times 100. 2%. As you can see, in the midpoint method we have 1.6% error. Here we have, think about the absolute as absolute, so 2% error. So we have seen that the midpoint method is actually provides a better way of calculating the integrals between 2 points. So I hope you have enjoyed my first video on numerical computing. So see you in the next video.